All right, the next thing we're going to talk about is expanding logs and condensing them. So we're expanding logs. There are really three main rules for those. The first is the product rule. And so we would start with the logarithm. For example, log base A, you'd always have to have the same base for all this sort, of x, y, so x times y. So if we think about exponent rules, if we are multiplying something with the same base, we're really adding them, adding the exponents. So this would be log base A of x plus log base A of y. Because remember, logs are exponents. So we're going to use log rules and exponent rules pretty similarly. And we have the quotient rule. I could spell quotient, that'd be great. Quotient rule. And that would be, for example, log base A of x over y. And so that's being divided. Remember, if you're dividing exponents, you're not really dividing them, you're subtracting them from one another. So that would equal log base A of x minus log base A of y. And then we have the power rule, which says that if you have something that is being raised to a power, so we'll just say log base x of n, that power, you remember you're multiplying. Power to a power means multiply. So in this case, you would have n, move that exponent to the front of log base A of x. Now, this also helps us understand why those log properties of if the bases match, that the answer is just the exponent, because this cancels to 1 and the exponent goes in front of it and 1 times anything is itself. So we're going to be using those properties as we move along and do some examples today. So our first one, we're going to just start off with something pretty simple. Example 1, log base 5 of x over 7. So we're going to identify this as division. So we're going to be using subtraction to simplify, expand this. Log base 5 of x minus log base 5 of 7. It is important that you write that subscript of the base 5 because these properties don't work if the bases aren't the same. The next one we're going to do, and we've got natural log. Now these properties work with natural log as well, of x squared y z to the third. So natural log, I'm going to write this out first, just separated as addition. Natural log of x squared plus natural log of y plus natural log of z to the third power. But now I'm going to take care of that power rule and move all my exponents as coefficients. So 2 natural log of x plus natural log of y plus 3 natural log of z. Let's take a look at a couple more. How about, let's see, log base 9 of the square root of x over y to the third power. So we look at that one. We see that we have a square root of x. We're going to change that into, just right off the bat, log base 9 of x to the 1/2 power over y to the third power. And now I'm going to split that apart into subtraction. So log base 9 of x to the 1/2 minus log base 9 of y to the third power. And now I'm going to move all those coefficients to the front of each of the log problems here. So 1/2 log base 9 of x minus 3 log base 9 of y. And the next one I'm going to do, log base 5, example 4, log base 5 of 5x over y to the 8th. Now we've got a couple things going on here. We have addition and subtraction, because addition for the multiplication piece and subtraction for that division. So log base 5 of 5, oh, look at that, we know what that is, plus log base 5 of x minus log base 5 of y to the 8th. So this, we know that actually goes away and becomes 1. So we have 1 plus log base 5 of x, and I've moved my 8 and coefficient log base 5 of y. So that'll be my final answer there. And let's do one more. All right. Let's do a crazy one. All right, here we go. So log, common log, so no base here, but we know that's going to be 10, of w to the 5th power, the 4th root of x over y to the 7th, z to the 2nd. So as we expand this, you can think of this as the numerator and denominator. So the numerator is being subtracted from the denominator. So both of these terms are in the denominator, so they're both going to have a subtraction sign. So if we write this out, log of nothing, base w, or base 10 of w to the 5th plus log. Now, 4th root means my fractional exponent is 1/4. Log base x to the 1/4 minus log of nothing, common log of y to the 7th minus common log of z to the 2nd. And I keep trying to write it as subscript. It is common log, z to the 7th. So these were both subtraction. You can kind of think of it as if I had the numerator subtracted by the denominator or divided by the denominator, what I end up doing is I'm actually distributing this to both terms because they're both in the denominator, so they're both being subtracted. So they do need that negative for this to be fully expanded. So log w, we're going to move my 5 in front. So 5 log w plus 1/4 log x minus 7 log y, or loggy, minus 2 log z. All right, if you followed that one, then you're in good shape.